what's the difference between automation and autonomy?
That's a great question, and I think this is a sort of a critical piece of demystifying the usage of these words in a lot of these technologies. So, when you think of automation, it is really something that is human defined, human scoped, human implemented, and then machine executed. So think of something that is a highly repetitive process, but one that isn't very doesn't change much. And in that case, that's like a assembly line or something that is very automated in the sense that it doesn't change. The problem there is that if anything changes in the environment or modifications to the process or something new has to happen, it still requires a human hand to intervene, restart, repair, rework, etc. And then once it's been changed again and the human hand has finished all of its work, then the machine can take over and perform that repetitive process. But out in the real world, where you can't control the environment, you can't control all the variables. That gets really difficult to manage. You either have to do a ton of pre-work and a ton of planning ahead of time to handle all the edge cases and that sort of thing, or you're sort of constantly restarting or changing the process, which is also a ton of work on the human side. Versus an autonomous system takes on some of that resiliency and takes on some of that sort of human thought, the human hand, so to speak, where you're just defining a high level mission objective, and the system self defines how it responds on a lower level, and so it can respond to changes in the environment or changes in the specifics on the ground level, where the human doesn't have to intervene necessarily, and
Do
that's
you,
where it gets interesting.
do you see any bridge between those two? Like, do you think
Mhm.
that the like automation is the like prerequisite for the autonomy, or do you think that it's like very independent?
Not necessarily, but you do see there's places where each are more appropriate, right? Like it's sort of a different paradigm in a sense. And so from a practical perspective, if you want something that is very, very consistent, highly repetitive, and it's kind of a known scenario, automation is great. It's very consistent. It's manufacturing lines are the great example. It's something where you want it to be done exactly the same every single time, and you can control the variables in that scenario. And so that's great. That's a good use case for an automated system. And in the grand scheme of things, you probably have an autonomous system that then can trigger an automated sort of subroutine in a sense, right? If you get to a scenario where you have a very repetitive sort of subcategory, then it's a great spot for that system to then take on and initiate an automated subroutine. And in this case, also, it depends on where you allocate resources. So an autonomous system, essentially is thinking about things more. But if you have something that doesn't require that level of thought, doesn't require the variability, then the automated system already created and defined a lot lower overhead from a cognitive perspective. So you may trigger that subroutine to handle some portion of that. And it's a similar kind of structural model to, if you think about the current LLM categories. There are parts of that world where you want the thinking machine to do some of it, and then there's parts where it gets repetitive enough where you're like, no, I want standard, essentially handwritten software that is doing the repetitive thing, and you trigger one or the other depending on what the right use case is.
Is there somehow going into this like algorithm or the like the equation, the ability to like absorb the risk, like because you just mentioned that with the automation you basically are very strict about what needs
Mhm.
to be done, how, and
Yeah,
like there is like zero option for variability, right,
yeah,
with the decisions. So
absolutely.
I think that there might be like use cases that could be done either with one of those.
Mhm.
How would you define, or how would you? When do you think it's better to go
Mhm.
with the automation, and when with the
Yeah.
autonomous system?
It's a good question. I I think the real answer is you won't know until you kind of test it in the real world. And so uh,
That's fair enough.
you can run a lot of scenarios here, but from I would say in general, if you know enough about the environment where you can say define a set of parameters that are 99% consistent across your operations. And then that 1%, you just sort of make an explicit error handling of, if it falls out of those categories, then, land safely or stop operations or whatever, you have some sort of specific error handling. Then in that context, that's a good use case for an automated system, especially if it's something that is done regularly, consistently, and you need it to be done in the same way. Where you have a lot more use cases for the autonomous rather than automated is where that it's going to be a more complex or complicated environment, or that it's non-static, which is to say that it's probably going to be changing and it won't be the same every time. That's where you start to need that next level of sort of cognitive compute, right? And in most of the physical industries, that's more the scenario, right? When you get outside of the highly controlled manufacturing floor and get onto logistics and places where people are moving things around, as well as machines, as well as you're storing work in progress, or you're storing stockpiles of things. Like those are environments that are changing on the minute basis, an hour and daily, et cetera. And so even if you go and create a fully automated system there, you're not going to be able to handle every little eventuality of how the environment changes. And so that's a scenario where autonomous systems are much more aligned in order to accomplish the missions there. So and in between, there's probably a set of automated use cases where you could do it with an automated system, but it would take a ton of work to try and plan for all the eventualities. And so there's sort of a trade-off curve where autonomous systems end up being more economical and more likely to succeed on sort of a curve there. And at either end, it's really obvious, and in the middle, you sort of have to make a judgment call these days,
Mm.
anyway.
Maybe for a general public, the closest thing how to think about the autonomous systems, or where they can actually like try it or read about this, is probably like cars, right?
Mhm.
Tesla is the best example of this. And if I understand right, there are like different levels of the
Mhm.
autonomy. So could you please just explain it to me? Like, I'm 50 years old. Like, what are these differences? Like, what levels
Sure.
of autonomy there are?
Yeah. So, a group called SAE defined the self-driving car sort of levels, which goes, 1 to 5 or 0 to 5. Um, and in that context, you basically go from at the lowest level is just human doing everything. No automation, no autonomy, no systems that assist in driving or object avoidance or anything. And at the other extreme, at full level 5, is a human never interacts at all. May not even be aware that the system is doing things. And so at either extreme, you have sort of like really obvious endpoints, and the sort of the trend in between, 1, 2, 3, 4, goes into the how do you add in incremental capabilities on the autonomy side. And you can think of it sort of as taking mental tasks off of the human and putting it onto the machine. And so in the very beginning, it's level 2 is focusing on really simple things that aid the driver, where the driver is still maneuvering the vehicle, but being given aids to help with maneuvering, or
So
safety
like
aids.
like for example, if it's holding me in lines, for example, or something like that.
Yeah, exactly. Like driver assist these days often is in sort of the level 2 category, where it's cruise control plus lane keeping, and can maintain speed but also slow down when the car in front slows down, and that sort of thing. It's helping to helping the driver to drive and performing a little bit of autonomy under like specific bounded conditions, right? But it can't, like a level 2 autonomy is not gonna, say go from this location to that location without me touching the wheel, right? That's further up the sequence. So on level 3, you have sort of hands off, more advanced, where you're adding in layers of autonomy. You're taking more load off of the people. Level 4 autonomy in that context is the operator, the driver is not driving. It's giving, it's taking in understanding about the environment and making decisions about route and speed and safety and that sort of thing. We'll change lanes, we'll take an exit off the highway, we'll make turns, and understand elements of the environment like a stoplight and a stop sign, a speed limit sign, all that kind of stuff.
So
And
you are sorry, you are still like making the core decisions, but only like you are only like guiding the system through the process, right?
so in level 3, that's true. On level 4, it is sort of it is an autonomous hands-off system in many scenarios, but not all scenarios. So you will still, as a human, say, I want to, go to this destination. You'll input it. You'll also be involved sort of with oversight and, in most cases, especially for cars anyway, there's an additional layer of like legal liability, and you're required
So
to sort of keep your hands on that sort of thing.
yeah,
Uh,
exactly. That's what I wanted to ask. Like, if it's something similar to like it's going autonomously, but you still need
yeah.
to like have hands on the wheel.
Yeah. So, and this is where it diverges a little bit from systems like ours, where the equivalent level 4 is for us is a little bit more high level. It's a different sort of implementation. Obviously, we're not on public streets and interacting at 60 miles an hour, and it's a somewhat different scenario, different set of problems. We operate more in unstructured environments, industrial environments, that sort of thing. Um, and so the levels are sort of a corollary here. Like if you think of, level 1 is a human drone pilot just piloting the whole time, right? Flying it themselves. There's no aids to navigation or anything like that. As you get up through to, like level 2 might be, you have like a position hold. If you take your hands off of the sticks, it's taking very basic GPS, and you have some aids to navigation, maybe some very simple object avoidance with a camera or something like that, but you're still piloting. Level 3 is more like adding in object avoidance, and or putting in GPS waypoints, and giving it sort of an automated path with some very lightweight, like object avoidance, in that sense. Level 4 is where our systems operate, and that's where the operator is not flying the system at all, and you instead have this ability to define the high level mission objective, and then the system self defines everything from there. And so it's the ability to run from there without without the human operator interacting at all. You still have some oversight. You can intervene if you want. You can get streaming data for the whole system, but otherwise it's running on its own.
Mm. And the highest level, the number 5, then would be like something like when we are now speaking about AI agents, that you just give them
Yeah.
like what you need to achieve, and it's going to do all the decisions.
Yeah, on like a super macro level, right? So the end state for what we think about in our category is, we talk about continuous, ubiquitous digitization. So if you own a physical enterprise and you want an updated digital model of your whole sort of physical industry, what the end state is you want these systems just continuously going out, digitizing parts of your business, buildings, infrastructure, et cetera. And you don't want to be defining every individual mission or like initiating them. What you want is the systems just going out and gathering the data when it's needed, when it's time to. And so that's a different kind of structure, but that's like a level 5 autonomy where you don't have to worry about any of the environments. It can operate day, night, fog, indoor, outdoor, et cetera. and you can find all the use cases there.
We have in person audience there.
Yeah, so my
Hi.
son's going on. So that's a scenario where or an example where level 5 autonomy is sort of in place. And so, our vision is to tackle more and more of these capabilities, implement them for specific industries and use cases, and then over time, you start to gain more of that flexibility, and the systems are able to self manage in all those scenarios.
So where do you fall in these categories with the Exyn solutions?
Mhm. So we fall in the level 4, and specifically what we would call 4B. And so within the context of level 4 autonomy, again, this is the operator is not flying, but you're defining a high level mission objective, and the system self defines flight path and speed and safe navigation corridors, and decides when it's completed each sub objective and the overall mission. And 4B adds in some environmental classification understanding. So uh, registering or classifying elements of the environment and taking action based on that understanding. So, a really common scenario for us is if you're in a constrained environment, like a tight environment, then you might kick up a cloud of dust from a drone, and a cloud of dust will appear to a raw sensor stream as being a solid object or like a wall, something that you can't navigate through, even though it's not a solid object. You could go through it, but the sensor won't read it that way. And so our systems classify that as dust, and instead of treating it as a non-navigable wall, it will instead say, okay, we understand that this is navigable, although with caution, because it's still a difficult environment. And you still have to look for solid objects that are within that dust cloud. So you can't just say, okay, it's dust, just barrel through it. You still have to look for solid objects. So the filtration of the objects versus the dust is still a complex topic. But in those scenarios, that's where you're running another layer of understanding on top of the core autonomy that adds in the environmental understanding and allows you to take action based on it. So much more likely to succeed in the mission. It's improves safety and likelihood of maintaining autonomous navigation. Another scenario where a human does not have to intervene. So those are examples of how level 4B builds on that sort of generalized level 4 autonomy. And so the use cases now often are just taking that core capability, looking at elements of the environment for whatever use case you're operating in, and making sure we can understand and operate within those scenarios.
Mhm. For example, with digital twins, there is like never-ending discussion, like what is and what is not the digital twin.
Yeah.
And do you think it's something similar happening in your world of autonomous scanning? Like,
Mhm.
do you think that the word autonomous is overused, or do you think that it's used like
Well,
accordingly?
I think for sure it's overused. Even where it's appropriate, it's everyone that is in drones or robotics or vehicles is using it in some form or another. So it can get very complicated, and I would have to imagine that buyers or consumers are getting kind of tired of everyone saying, "Yep, it's autonomous," etc.
Yeah.
So I think that's an ongoing challenge. For sure, the use of the term is complicated. I think that's why it helps to sort of set the stage on what are the levels of autonomy, or what is it autonomous for? What does it accomplish? What does it get? Because at the end of the day, a customer isn't going to buy something just because it's autonomous because it sounds nice. They'll purchase the autonomy, or they'll use the autonomy if it accomplishes a specific business outcome. And I think that's the key part, right? Is that it needs to be something valuable and usable, something that is tangibly better than if you were to just pilot it yourself.
Several times you mentioned variables,
Mm-hmm.
incomplete information,
Mm-hmm.
lack of certainty. Uh,
Mm-hmm.
do you think that this is like the main component of why the autonomous systems are needed?
I think it's a big piece of it, right? A lot of the complication of operating out in the real world is that you can't control every single variable. You don't have every single element of information, and even if you did, it takes a huge amount of planning to try and cover every eventuality if you're sort of planning for this by hand, right? And so it's a mix of, you can't predict everything, you can't take in all of that information. The variables are still going to impact you. So yeah, the autonomous systems handle a lot of that. That's kind of the reason why they're taking on a bigger portion of the workload. But I also think that autonomous systems are now sort of entering into the mainstream a bit more and are being adopted by industries because they're finding scenarios where people are able to pull out of the most difficult or dangerous environments, and the systems take on some of those roles, and it gives especially experts the ability to focus on data analysis or doing higher level work rather than just being trudging through the field day after day, or in like a survey team, it can mean that you spend less time just driving to and from a bunch of different sites, and instead you can get the data and you can analyze it and figure out where best to spend your time. So I think it's a mix of reasons why things are being adopted. At the end of the day, autonomous systems are another tool in the tool chest for folks, and where it can give them a better outcome, then it's an obvious yes. And everywhere else, it's sort of it's a learning to adopt.
Yeah, this is exactly where I'm heading with this question, because for like the core value added for automation would
Mhm.
be, let's do it quicker, let's leave out the personal, let's just do this uh, easily and save time.
Mhm. Yep.
With the autonomous systems, it can be also about the time, but
Mhm.
it's very much also about the safety, right? So
Mhm.
my question for you would be, like, where do you see the more potential for the future of this market? Like, is it safety versus laziness? Like,
Yeah.
what has a
Um,
great potential?
yeah. So there's what I'll call the low hanging fruit here is all of the most dangerous elements of um, people's operations. Those are the places where autonomous systems go first, right? Because you keep people much safer. You reduce cost and overhead, and I mean even things like insurance or liability, because you're removing people from the most dangerous scenarios. Those are sort of the low hanging fruit. So a lot of times, autonomous systems, especially, start in those kind of environments. That was true for us in underground mining. Our first use cases were pulling people back from the most dangerous parts of the survey job. I think over time, then you look at other categories that are either very repetitive or very difficult to get consistent information, or it's really difficult to access. If you have to do scanning or data collection where you need to build like scaffolding to get up close enough, or you need to have a lot of lack in coverage where you would have to put a tripod scanner in a whole bunch of different areas to remove shadowing or something like that. Those kind of scenarios, an autonomous system then can cover it all really quickly, and so then you get these big jumps in efficiency, or um, make it economic to do something that wasn't economic to do before. So it sort of expands the portfolio of what's possible for those teams. So those are kind of the next categories, and then over time it just becomes sort of an industry standard, like a norm for a team, and then they absorb more and more into it.
Mhm.
And so there's sort of it's like an adoption curve for startup technology. You get the early adopters that have some sort of very acute, really specific need, and over time, as it becomes more ubiquitous and people understand it better, and it's a lower risk to adopt it because they have heard and seen enough to understand that it's trustworthy. Then you get broader adoption at that point.
Mhm. We have questions from the audience.
Mhm.
This is a two-part question, but we will go through your use cases later. So I would
Mhm.
leave out right now for the first one. But the second is, when is an autonomous system economically justified, and when is it more cost effective to hire humans? And I would just like to add to that question that We will discuss about the problems and how ready is
Mhm.
the system and everything else later.
Sure.
But for the sake of this question, let's pretend that everything is working perfectly and the
Mhm.
autonomous system is like 100% ready to go.
Yeah.
Uh, where do you see like the break-even point? When do
Mhm.
you think it's better to choose autonomous system compared to person?
Yeah, I mean, the complication in that question is we don't always, as the supplier, we don't always know what the alternative pricing is for. We don't know what wages people are getting paid necessarily. So we have sort of a generalized sense. Right now, most of the use cases where we are finding really rapid adoption is where you have very capable, very well trained people performing work that is not maybe the best use of their time. So in the case of like a geospatial survey team, those are folks that have a lot of experience. They've probably done years in the field. They might have an advanced degree. They are doing analysis of the data that comes out of these capture processes. But they still spend a big portion of their time sometimes out in the field, just carrying a capture device around or driving to the work site and recapturing things. And so a portion of their time is really inefficient, and the best application of their experience and their talents is a narrower portion. And so from a business perspective, you might say that that's an inefficient allocation of that intelligence capability. So in those scenarios, allowing that person to focus more time on what they're trained to do, which is the analysis and their best use of mental load, and then letting an automated or autonomous system take on the sort of the rote capture of things. That is a pretty obvious one because you're trading off like efficiency and sort of high wage labor, where um, if you're looking at people that are hired just to do sort of manual labor that may not be very well trained, or they're not experts, or it's like hourly labor, folks that are getting paid minimum wage or something like that. In those cases, it doesn't make sense to replace probably, um, or there's scenarios where it sort of aids. And so in most cases, we find that it ends up being like a sort of a collaboration between human and machine in this sense. And so there's plenty of industries that don't make any sense for us right now to go to because there's not a good trade off there of labor costs and the price of the system, because our systems are not cheap, and so it takes certain scenarios where it's really required. But another piece here is that a lot of our use cases are where it's just not possible, even with human labor. And so in like underground mines where we got our start, there's inaccessible data that you just couldn't get from a person without an autonomous system. And so in a lot of cases, you're not actually trading off against labor, or you're not even trading off against other systems. You're creating a new category that isn't able to be performed. And this is also the scenario for a lot of infrastructure monitoring and scanning, where it wasn't economic before, so people just didn't do it. They wrote the standard and they designed around, do it every 5 years or something like that, and hope you catch it fast enough if something goes wrong. Whereas as the automation of this and as the repeat speed, the higher speed of capture means that you can do things more regularly, still at a lower cost, and do it without drastically increasing your labor pool. That then changes what you can do from an operational perspective. And the final piece that I'll add here also is like in most of the industries that we serve, one of their biggest challenges is finding people. And so to some extent, it ends up not actually being a trade-off of labor cost or economics. There, it's we can't find anybody, so we need this team that exists here to be able to cover what would have been three teams before. So how do we make them more efficient so that the rest of our operations don't fall behind? And so we haven't run into much of a headwind from a labor cost perspective in any of our industries.
You kind of fucked up my next question because I'm I'm, I'm quite known for my very aggressive hooks on LinkedIn where I say
Mhm.
like the surveying profession is dead or photogrammetry is dead or whatever, right?
Yeah, yeah.
And this is something that I'm very often thinking about because I'm coming
Mhm.
from the reality capturing world. Okay, so
Yeah,
so like my core business is still laser scanning and photogrammetry,
yeah.
and since like I'm seeing daily new coming technologies, softwares,
Mhm.
hardwares, and the
Yeah.
workflows. Me personally, I'm really afraid of the future of
Mhm.
the core business of mine because
Yeah.
I really believe in the future where like
Mhm.
there is very few human operators of scanners and
Mhm.
most of the jobs being done autonomously. If I'm speaking about the future, I'm thinking about like 5 to 10 years.
Mhm.
What's your feeling about it? I know that you want to like protect your position and say like we will need more people still and everything else, but
Yeah.
like really, how do you feel about the future of scanning operators here?
So I think the way that I think about this, and it doesn't even matter what I think about it because you can watch it playing out in real time, which is that the the job changes the specific role of someone carrying around a tripod scanner and doing all of these doing a whole field survey. That specifically, I think that'll go away, but that same person is changing what they do a little bit. And so I think that even in the 10, 15, 20 years out where you have enough autonomous systems that they're just sort of continuously capturing the physical world digitally, even in those scenarios, it's still valuable to get out in the field every now and then because there's always things that are not captured completely. And it's important to contextualize the digital model with being foot in the field sometimes. And so what I think you're going to have a lot more of is you're going to capture many orders of magnitude more data. You're still going to need people that go and say, okay, I understand the lay of the land here. I need to go and target my visit to site to inspect this thing that isn't quite clear on the point cloud or the mesh or the video or the photo or whatever it is. And you still need people that are putting those things together, but the cognitive load moves somewhere else. You're using more tools to do the overall role, like the role of someone that is capturing data and gaining insights from it. That used to be just person doing it in their head as they're out in the field. Then it added more tools to it, and in this case, the tool set is shifting more digital, but it's still a person making that decision at the end of the day. Of I need to know the status of this construction project. Are we good to move to the next phase or no? Are they doing the right things? Yes or no? Like a program manager or project manager is still using those tools for all those things. So I think the specifics of what people are doing will absolutely shift. I think that the role will not go away. I think it will change quite a bit. And I mean, you're seeing this in the software development world, right? Everyone super worried a couple years ago about software development is going away. There's no one's going to be a programmer anymore. But we're hiring more than ever, and you have people being more productive. You're building more, but you still need really capable people that are running that process. And I think that that's still true. And I'm an optimist on technology adoption and all these things, but I'm a pragmatist in the sense that uh, it's never quite as good as we hope it will be. And there's always a need for a human hand to sort of guide the mission design or understand if what you're doing is actually what you need, right? It requires that sort of critical thought level, and I don't think that's going away anytime soon. We certainly see it in a lot of industries where people are able to be more productive, and they're using the speed of capture and the autonomous nature of capture to gain more opportunity to run human thought through the process.
Mm. Uh, in last 2 weeks, I have done 2 posts about
Mm-hmm.
some of my predictions for the market of surveying profession, and also about the
Mm-hmm.
SLAM versus TLS scanning.
Yeah.
I don't want to go deep into those posts, but there was like one thing that connected them, and it was my observation that we are on a growing market. Like the
Mm-hmm.
reality capturing is a bullish market, and we
Mm-hmm.
are still at the beginning.
Yeah.
This is not a zero sum game, right?
Mm-hmm.
If you are scanning something with SLAM, it doesn't mean that it won't be scanned with something else. And like we are not taking jobs from each other.
Mm-hmm.
We are
Right.
on a growing market, and there will be still more and more jobs.
Mm-hmm.
And it's not like growing. It's not going to grow like about 20% or 30%. Like this is going to be exponential growth, I
Mm-hmm.
think, for
I
the
agree.
future.
Yeah.
Because all of those new technologies, slams, iPhone LiDARs with the RTK correction, autonomous scanning, and everything else, this is actually like not replacing the current jobs. This is
Mm-hmm.
actually expanding the whole addressable market there,
Yeah.
right? So,
Mm-hmm.
so the even though I'm saying that I think that the people will be replaced in scanning, it still means that on a like if you look at the whole market, there will be more people, but
Mm-hmm.
the portion of them and the share market of people that are doing like the scanning with the human will be smaller, but
Mm-hmm.
just because the overall market will be like much bigger.
Yeah. No, I totally agree, and I think you're seeing a lot of that adoption now in like every industry category is finding new niches where they are going, oh, we can use that to improve production operations, or we can use that. We have people using it for forestry, where they're scanning, tree trunk sizes, and getting the topography underneath tree canopy from flying systems below tree canopy, which is pretty wild. And you're getting all these use cases that weren't necessarily things we predicted. It comes from getting out in the field and just sort of demonstrating existing capabilities and use cases, and then asking the question of those end users, like how would you what would you digitize in your world, in your physical world, if you could? And
Mhm.
let's try it. And so you get some really interesting use cases out of that approach. And one of the most interesting parts is that folks who have our systems end up coming back to us and say, "Hey, we tried this other crazy harebrained idea, and now we have a rig that scans the underside of a railroad bridge, which wasn't quite designed for, but here's the model. Isn't that cool?" Or folks mounting it on maritime survey vehicles, where we're then combining it with hydrographic readings, and you're getting the ability to scan above and below water in a single data model. Like all these kind of things are fascinating market categories that we didn't necessarily define that use case and go out to the market like, you should do this. So it's end users, people that are pulling the technology into their worlds.
This is very important point for any developer of either hardware or software. Like get it to users.
Hmm.
Like you would be surprised how they will use your solution. And
Absolutely.
like I'm always giving this example with the iPhone LiDAR, because the
Hmm.
sensor was meant for something totally different than it's using today. It was just for
Yeah.
the depth, for the better recognition of the face, and
Hmm.
for better pictures and so on. But users are crazy. They started to use it for scanning, and
Hmm.
it opened like totally new market for the
Yeah.
whole iPhone LiDAR Pro, iPhone
Right.
Pro. And it goes for many different hardwares
Hmm.
and softwares. So guys, if you like, if you are in a business of development of anything, like your goal should be to get it, if possible, for free to as much people as many people as possible, and just like receive the feedback, let them create, let them explore what can be done with this, because you have no idea like what people are thinking
Yeah.
about, what businesses they are in, and so on, right?
Yeah. I mean,
uh
there's a great example for this actually also, which was in our very early days, we were drone first, and we had a mine user that was trying to scan like a drive down drift in one of their mines. And it was a use case we hadn't considered. And they just took the drone, duct taped it to the hood of their car, turned on the scanner, and didn't fly the drone obviously, but they turned it on and it was scanning. And they drove 10 kilometers down this down this mine approach, and then came back and like, hey, look at this, isn't this cool? I'm like, what are you doing? No idea for us. We didn't know what we didn't know in that category. And so we're like, so being able to mount a scanner to the front of a truck, use case, got it. And
I had a similar experience like just the other day when I was speaking to the head of marketing from FG Dynamics, and we were discussing different scanners and so on, and they have this very small one which is really like very easy to hold and very small, and I got this question from the audience like, we need to scan the chimneys. And it's not these big industrial, but like really on a family house where the diameter is maybe like 15 centimeters or so, right? So it's very small. And I was like, okay, but I don't think it's going to like register and align correctly, because it's very narrow, it's
yeah.
very closed environment and everything else. But then I started to think like, what if there was some mount that would have some kind of IMU? It would know exactly like in what distance to its base the scanner is. This way, there is no need for the Z positioning
Mhm.
of the scanner. It would just collect the basically 2D data, and
Mhm.
it will always know where it is in a Z axis, right?
Right.
And this way, it could be possible to
Mhm.
find solution also for this. So I'm not trying to solve this right now. I'm just
Yeah,
giving an example that people
totally.
are dealing with very different shit every day. So you
Right.
just need to give them the
Mhm.
ability to try something and to
Yeah.
find out
No,
new
it's
ways.
wild. People are creative.
Yeah, absolutely. Ben, can you give me just a brief like information about your background? From
Mhm.
what I understand so far, like everything you have done so far, it was somehow connected to the lack of information and uncertainty. So can you just tell
Yeah,
me like where you're coming from?
sure. I think my background as I was a computer engineer in undergrad, and spent a lot of time reading about the history of technology development, and how technology infuses with society, and all kinds of fun stuff. There was I had one of my minors in undergrad was the history and sociology of science, which was a fascinating topic, and well, I could wax on that forever. But so I originally an engineer. I started my first two companies in college to help pay my way through. I was a naval officer for 6 years. Did a few tours, operating in the Middle East. I spent then another 6 years commercializing energy systems when I was at Lockheed Martin.
Can we stop?
Yeah.
You mentioned that you were operating on the Middle East. How
Mhm.
does it make you feel right now with what's happening there?
Um, it's a tough one, right? Like there's the difference between the ground level, the people involved versus political decision makers, and sort of international dynamics. I feel sad for anyone that's involved or in the crossfire. It's horrific on every side, and most of the folks on in any country are not thinking about political dynamics. They're just like, look, I'd love to live my life and spend time with my family and that sort of thing. So I think I'm split between or it lives simultaneously, right? Like there's a lot of stuff going on there that it makes me really sad, and I don't have any particular solutions for how we would do better. But I wish we could find a way for to not involve ordinary folks in all that stuff.
I
Um,
understand that you had some missions, some tasks, and everything else. But like during those years, were you able to like meet some local people, like make some relationships?
yeah, No, that was one of the most fascinating parts of especially my first tour, where I ran something called like VBSS, which is Visit Board Search and Seizure, and it was basically small boat teams that would inspect commercial vessels to make sure there was no smuggling of arms or oil or people or anything like that. And the vast majority of folks that I met were they were annoyed, but understood, and they're like, look, I get it. This is it's a United Nations resolution. It's a coalition of folks. I was working with the Polish Navy and the French Navy and the Australians and the British and like all kinds of folks. And the folks that I would talk to on board these ships are ship captains for commercial shipping that go all over the world, and they had such this interesting perspective of cultures meshing from every continent and every major port in the world. And it was a really, I mean, I was 23 or whatever I was, and so I didn't know that much about the world. So it was really fascinating to hear about all the different cultures and how people were, how people viewed the United States or viewed European countries or viewed the countries in the Middle East or wherever. And it was just a fascinating sort of mind expanding experience to meet a lot of really fascinating folks.
So especially with the situation around the Hormuz, like
Mhm.
you must feel it quite personally because you were actually working with all those vessels
Yeah, I
and
was
and this.
I was over there. I mean, it's a complex complex environment. I
Mm.
I think some of the smartest minds in the world haven't been able to figure out how to how to make it go. So I won't pretend to have any kind of solution in mind. But yeah, I feel for the folks involved, and I was on some of those ships in the Navy. I don't envy their extended deployments and the folks that are getting their lives turned upside down. It's tough
Mm.
for a lot of folks.
Sure, sure. What was your way into Exyn Technologies? Like,
Mhm.
were you offered the job? Were you applying? Were you
Yeah,
headhunted? Like, how did you get
yeah.
into Exyn?
So the context here is that after I sold my previous company, I was sort of doing the road show, the personal road show of you know introduce me to people working on interesting things, and talking to what I call like ecosystem connectors, investors and accelerator operators and incubator operators and folks that just connect people throughout these ecosystems. And so, in the course of that, I obviously met so many fascinating people working on these really cool technologies. So I built like a consulting business for a while, just helping these folks sort of stand up their businesses and think about commercialization and how to build a founding team and all that kind of stuff. Through those conversations, I met some investors that were looking at Exyn for the Series A. It had been spun out from the University of Pennsylvania about 4 years prior to that. They'd done a bunch of the foundational research and were preparing for the first one or two pilot programs. And so those investors said, "Look, we love the technology, we love the team. It's very smart folks, but no one there has built and sold, commercialized a business. So would you be interested? Because we'd like to invest, but we'd really like to see an operator that has done deep tech commercialization before." And so I was pretty fascinated also, and that was sort of how we got connected. And then I did sort of a strategic plan as a test run for them. And then the CEO basically said, "I like the strategic plan. You want to just execute it as a COO?" So I dialed back some of the projections and said, "Yes, now I will. Now I will do it." But yeah, so I've been with the company now for 7 years, and we've gone out to the world. We're in 30 plus countries. We've got channel partners all over the world. We do a lot of collaborations with drone and robotics builders. We
I
license.
want to get
Yeah,
into this because
yeah.
I'm interested in more details. I just wanted to
Mhm.
mention that you recently went public with the company.
Mhm.
You went
We
through
did.
IPO, and
Yep.
I don't want to like spend time on this, but for me, and you can confirm or
Mhm.
like dispute this, but for me, going public, especially in the United States, and going to the Nasdaq,
Hmm.
you must have gone through so much due diligence and
Yeah.
checkups and licensings and
Mhm.
like I don't know, what was
Yeah.
the process like? How did you feel? How long did it take?
I well, I it was annoying and frustrating, and interesting. I learned a lot, of course. Yeah, I like the detail with which you have to go through financials and audit and inventory and all of these things. It makes sense. Like you're putting all of this information into a public market where retail investors can invest. So the exchange and everyone involved needs to know that the what you're talking about is true and trustable, so that people can invest. So I get it. It is annoying though, because we have to go through. I think we did like 4 or 5 rounds of audits of like inventory where it was like one system was mislabeled, and so we're like, it doesn't match up. We're off by $20,000 or something like that. And they're like, well, it doesn't match, so we got to go do it again. I'm like, man, all right. But we got it right, and now all of our systems are better off for the transition, and it set us up for growth in a lot of ways because it
Do,
it yeah.
do you think that, like, beside the fundraising and being able to sell shares and just
Mhm.
get better financial wise, do
Mhm.
you think it's a good also like a credibility and reputation on the market when you say that you are actually a public company?
Yeah. Oh, well, I hope so. um, I think, I inherently believe in the company, and, think we're doing great things. Um, to see it validated from investors, retail investors, and institutionals, obviously feels good. It does offer some credibility when we're talking to partners or even customers too. As an early stage startup, one of the risks that customers will evaluate is, do I think this company will be around in 2 years? If I buy the product, will they be able to support it for the duration that I'm using it? And so at the early stage, that can be a reason not to buy, especially for a larger company that is doing risk management on a vendor approach. And so going public is one more sort of backup to, they're a credible company. They're going to be here for a while. I have some insight into how they're doing. So it's a way to de-risk the purchase from an enterprise perspective as well. And
Mm, mm,
so
mm, mm.
so I do think that's helpful, and it's a means by which you can go more broad as well from a industry perspective.
This will be just my personal opinion without much of a sucking up to your company, but I think like when it's something similar to when you are buying house in different city and you don't really have time to go there and check everything. You don't
Right.
understand everything, but this all this due diligence and the fact that you went public, it
Yep.
I would like do the analogy with when you send some professional to check up on the
Mhm.
house, right? To do
Yeah.
all the technical
Right.
survey, to go through all the documents, all the
Mhm.
materials, to check whether there are some damages and everything else, and he will just come to, okay, this is ready to buy.
Yeah. 100%. Yeah. So it definitely helps. Right.
Perfect. Let's go back to the autonomous, because when we speak about this, it's, I think there are two parts. Like there is technology collecting the data, and there is some vehicle for it, right? So,
Mhm.
uh, can we just describe this? Like, what's your main part
Mhm.
of the solution, and to what different kind of vehicles you are connected and you can work with?
Sure. So our core technology is all in the software. It's combination of high accuracy mapping and autonomous navigation, what we would call self-contained autonomy. So within that context, it's software, but it has to touch the physical world at some point. So the question is always, what interaction with hardware is there? And so to make it the most flexible, we ended up developing a payload that goes on drones or ground robots or can be a handheld scanner or vehicle mount scanner as well, but is able to guide systems autonomously when you plug it in to those systems. So the payload often ends up being the majority of our business. It then has additional capabilities that are software licenses that you can add or subtract as you see fit. And in those cases, you often are buying the drone yourself, or you're buying the ground robot, and then you purchase the Nexys, which is our payload, and then you align whatever your use case is. You buy the right licenses for it, and then go to town and use the system. So our most common market entry point is someone purchasing a Nexys and the software licenses and some sort of set of accessories, which may be a drone or a ground robot or backpack mount or whatever, and
Mhm.
then they integrate it into their data
Is
workflows.
is there any list of the supported, like, I don't know, robodogs,
Mhm.
drones,
Yeah.
and like rovers or whatever?
Mhm. Yeah, we keep it continuously updated on our website. But the obvious ones, we support DJI drones and CHC Nav and Free Fly and Inspired Flight and a handful of others as well. And we work with drone providers also to integrate with them. We offer an engineering package that allows them to integrate themselves as well. We've had folks that purchase systems or even license the SDK, and we've never seen the system in person. They just integrate it and are off doing autonomous missions and capturing data, which is pretty exciting.
Okay, so if I understand right, you have producers of the so-called vehicles, so it's
Mhm.
robodogs, drones,
Yep. Yep.
rovers, everything else. Then you are developing the hardware, the basically a SLAM solution, right?
Mhm.
Because
The
you
payload.
somehow
Yeah.
need to collect the data.
Yep.
So it's a SLAM scanner, just
Mhm.
let's call it this way.
Yeah.
And then you have a software which not only captures and processes the data, but
Mhm.
is also uh, guiding the vehicle, right?
Yes.
Do I understand it right?
Yeah, exactly. So when you have the Nexus mounted on a drone, for instance, the Nexus is mapping in real time. It's creating the 3D model around the drone, and it is also using that to determine the safe navigation corridors or where it should go next to gather information to fulfill the overall mission objective which you've set. And so it will then give flight guidance to the drone. It'll control where it goes. It'll tell it, when to fly forward or when to land or when to continue exploring. And so our system is the one that controls the drone instead of an operator. So it replaces a human operator in that sense.
Maybe I would play one of your videos. So this is about the stope
Hmm.
mapping.
Yep.
Uh,
Yep. So this is a great example. So you can see this is a really complicated area. Hang on. Actually, if you want to pause right there, this is a great
yeah.
great point. So this is an example of an area where you're doing hard rock mining, and they're blasting this big cavity on the right hand side. And so that cavity grows over time as they blast more of the rock and they pull it out and then process it to extract the resource. Um, the problem is that after they set off the explosives, that's a really dangerous environment. And so it used to be that people would go right to the edge of that space and try and capture data with a lidar on the end of a long stick, or eyeballing it, taking photos of it, whatever. And so you both had people in a really dangerous environment because you have rock fall continuously. Like, people would die every year from those environments, and you also had the problem of data accuracy, because if you have a person standing at the very edge there, you can get good information from right near there. But looking up at the very top or further out, it's hard to get anything accurate there because it's further away from the point source that's collecting the information.
And it's also a lot of occlusions, I guess, right, in this
100%. Yeah,
environment.
you get shadowing, you get a lot of inaccuracies in the calculation. And so then once you have an autonomous system, you can start from way back in the corridor where it's known safe. There's no danger of rockfall or anything like that. And the system then flies down the corridor and then explores the extent of the stope, which is this cavity, and that means that you are far safer. It happens a lot faster, and you get a much better data product because the system is moving around to explore all those cavities or overhangs or occlusions. And so it's one of those rare scenarios where it's like a win 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 win. It's better in
Okay.
almost every way for it.
Can I play it?
Yeah, absolutely. Yeah, so this is I think it's a DJI drone
Okay. So
here.
what's the payload weight? Like what
Mhm.
kind of a drone can handle it?
The payload is something like I think 3 kilograms or something like that, 2.5 kilograms. So depending on the drone, but a standard DJI M350 or a FreeFly Astra Max or a CHCNev, I think X500, or there's a bunch of systems that can handle these things. But it's not a really small drone, but your standard sort of industrial size drone. So all of those types of models work really well. But again, there's a list on the website of our actively supported
Okay.
ones, and we can do all kinds of other ones. This visual right here is actually pretty
That,
interesting.
that's
Well,
that's I
yeah,
wanted to ask.
yeah.
Like this really caught my attention because if I understand right, you are not working like on a point cloud, but rather on a voxels.
So the system creates the point cloud in real time. What you see here is an abstraction of the point cloud to make it usable for navigation. So each of these voxels is basically determined to be either unoccupied, which is just nothing is it's open, occupied, which is if you get enough hits from the lidar in a particular volume within that cube, then it's treated as an occupied space. Or it's treated as unexplored and unknown. And so if you're doing an explore mission, the white voxels are the unknown areas where it's trying to push back the unexplored frontier, trying to find the areas that are not yet explored and determine whether they are occupied or unoccupied. And so in this case, the green voxels are occupied space, and open spaces is sort of in between, right? And so it's a way that it's a way of visualizing.
Occupied meaning also a solid space, like
Yeah, exactly.
something that you would collide with.
Yes.
These whites seem to be floating in the space. So
Mhm.
I'm just guessing this would be some kind of a gas or like s- uh,
So it
a
depends.
dirt
So
or
in some cases, it's just that we haven't reached far enough. We often will define a maximum range that is shorter than the range of the lidar, so that you can just be really confident that it's been sufficiently explored. And so in a lot of these cases, it just hasn't reached the space yet, so it's not within range to classify it as explored yet. But in some other cases, it's occluded by other things, or it's blocked by the field of view of the lidar or something like that. So you also have scenarios where uh, it is, if you have things that are moving in the space, you may have an unexplored area that is behind a moving object. That then, once the object is moved, you still have that unexplored space, even though it's not blocked by anything anymore. And so the system will go back and go near it so that it has then explored it.
Mhm.
Does that make sense?
for yeah. And I wanted to just mention for the people that are color sensitive, then when we are speaking about whites, it's on this picture is actually like yellow gray
Yeah,
ish something
yeah,
like
yeah.
that, but that's what we mean
Mhm.
by white.
Absolutely.
So I will just play the video.
Yep. So you can watch it pushing back that unexplored frontier as it explores. Um, yeah, and this is a great example of some of the dust clouds that come through, and you
Okay.
can see that sort of forming there. It's not treated as occupied space, but it does fly through it. Yep, and that's the payload right there. That's the Nexys, which can be used as a handheld scanner, but is often used to guide systems autonomously.
Mhm. So you mentioned that you can put it on a robot, on a rover. Can you use it also on a car?
You can use it as a scanner on a car. It does not provide autonomous navigation for a
Oh,
car.
of course, you would need to
Yeah,
car to be allowed to be
different things. Yeah,
navigated. No,
yeah,
no, no.
no,
That's
yeah,
what I meant to be
yep,
using it as a slam.
yeah. We sell a vehicle mount, and for a lot of partners, we also just give them the 3D models, and then they can manufacture like a creative mount for the system as well, which is also fine. We love people to be experimenting and finding new ways to capture data. So we've got a bunch of partners that do things like that.
Usually, slam companies don't like me because I often say that it really does not matter which slam company you choose because they all use the same LiDAR.
Right.
Uh, but but what I mean by that is that what you should care for
Mm-hmm.
is the algorithm, the support,
Mm-hmm. Right.
the processing side of the things,
Mm-hmm.
because it's only the fact that most of those are using the same or similar slam solutions, and also
Mm-hmm.
by physical means, like there are limits of how
Mm-hmm.
accurate you can get with the slams.
Yeah.
Just today I got a comment on one of my posts that, oh, this company is selling the slam that claims to be almost accurate, like the or close to the accuracy of TLS, which I commented like, okay, physically impossible, one. And the second, depends on how wide you can go with the range of close to.
Yeah.
so
No, totally.
so yeah. uh, how do you handle the registration? Because you are claiming
Mm-hmm.
that it's like not only about the autonomous processing,
Mm-hmm.
autonomous capturing.
Yep.
I I can see the problems with slams that usually when you go to narrow spaces, to long holes
Mm-hmm.
and everything else, you get these drifts and
Mm-hmm.
problems. So
Yeah.
usually slams are, if allowed, they are solving this with RTK correction or
Mm-hmm.
basically a GNSS antenna. Uh, but we are speaking here about the environment that is basically like GPS denied, right?
Yeah.
Like you have zero signal there.
Mm-hmm.
So you will just send out, I don't know how many thousands of dollars with the drone
Yeah.
somewhere into the mining zone and very dangerous zone.
Mm-hmm.
How can you be sure it will come back?
Well, 6 years of experience having to fix the problems is the real answer. But um, yeah, I mean, a lot of it is figuring out how to have the system avoid areas that it'll lose state. Um, some of it is making sure that operators understand when to use the system and when not to use the system. Some of it is taking a design approach that allows you to be flexible for when you have a fiducial or control point or GPS or RTK or whatever. So one of the interesting things is that what we ended up doing with our system is that we don't necessarily require the LiDAR fix. What we do is we assume that you have some set of localization solutions and it kind of measures the quality of that fix. The best quality one is the one that uses as primary sort of navigation. And then other localization tools can provide corrections to that. So if you, for instance, are going in and out of GPS coverage, you may have it, 10% of the time, but it's sort of here and there throughout the scan. Then you're able to correct global drift pretty accurately. You'll get down to, maybe a couple centimeters of drift over long capture if you're able to get a few GPS fixes along the way. Same thing with control points where you're able to use that to correct drift over time. If you have some known surveyed points, then you can sort of snap it to that known coordinate frame, and so you can greatly reduce drift in that context. It won't totally remove it, of course, but you're able to correct most of the global drift in that context. And in the same vein, on a sort of local frame, you're able to, especially if the system is operating autonomously, it will avoid featureless environments, and as it begins to get degraded state, it will actually remove itself. It'll backtrack towards areas where it has a better fix, and it'll let you know. It'll say, "Hey, this looked like it was a degraded environment. I came back, and let me know what you want to do next." And so then it's up to the operator of I really need that, and I'm okay with the risk, or I'll hand carry it for a specific area where I think I can get a better fix. Or you can also put physical things in the environment if it's an accessible area, and you just put physical objects here and there so that it just has the ability to latch onto those as features in the environment. So there's a lot of things that an operator can do to improve the scan. There's things you can do from a technology perspective to add in secondary corrections and all that sort of thing. So it's never just one thing that, like, there's no silver bullet here. There's nothing that just
Yeah.
solves it right away. A lot of it is making a system that is resilient to these changes, resilient to the sort of changes in environment, and tries to make it seamless for the user, obviously. So a lot of these are things that we learned over time as we found new edge cases, or we found where the initial scan comes out great, and then they extend it a little bit further, and then it starts to drift, and at some point it'll get across a threshold where they're like, it drifted too much and I can't quite use it. So then we go, okay, how do we solve that kind of a problem, and then how do we generalize it for other use cases? So it's an iterative process of making sure it works.
With the gadgets and tools that are less accurate and but very fast,
Hmm.
now autonomous, I'm always thinking about this like this ratio or this decision making, like
Hmm.
because when people say that it's not accurate enough, i'm uh, I'm saying, and especially with the safety, for example,
Hmm.
right?
Yeah.
So there's this question, like you can have maybe inaccurate data but
Hmm.
still data, or you can have no data, like which is
Yeah.
better?
Yeah. 100%. I think there's a lot of just momentum also, right? Where it is true of any industry, but we run into it from time to time in surveying too, where it's well, this is the way we do it. We use the tripod. Right? Okay, I understand. So you're used to having that level of accuracy, um, but you don't always need it. And so a lot of times, what we work through with them is, where does that data go? What is it being used for? To what end? What are you trying to do with it? And what we often find is that 80 or 90% of the data um, doesn't have to be 1 millimeter level accuracy, right? 5 or 10 millimeters is great. And so in those cases, oftentimes we end up building the base map with a Nexus oriented system, and then for areas where they need the most critical precision, they use a TLS, or they use something else like that. And in that case, it's great. It sort of combines the tool sets and allows them to focus their efforts on the right place, the right tool in the right place, right? And for those teams also, if they can avoid carrying 5 or 6 tools and carry just two, that's a great win for them from a logistics perspective.
Mhm. You can see these spots from Boston Dynamics almost on every expo and a trade show.
Yeah.
Uh, we can see humanoid robots and everything else. Where do you see the gap between what's looking good on the conference and what's
Mhm.
actually working in field?
Yeah. It's a good question. For a lot of these, there's a there's a transition of where does a particular tool work best? What are the actual advantages and disadvantages of it? And over time, we learn this and we try and help our customers understand it as well. A great example of these is, the Boston Dynamics Spot is such a cool robot. Quadruped gives you some advantages. You can go up and down stairs. You can step over obstacles that are not too high anyway. So it gives you a lot of flexibility in a complicated environment. Downsides are cost and battery life, compared to a wheeled robot, for instance. Um, you can carry more payload on a wheeled sled, but it needs a pretty consistent surface to maneuver on for a wheeled robot. Or a tracked vehicle is somewhere in the middle. It's a little more flexible in terms of what it can navigate, but it also is spends more energy than a wheeled robot. So there's a bunch of
Mhm.
interesting things here that then are trade offs. And so A lot of the physical robot manufacturers are not software developers, and they end up having sort of a rudimentary navigation system, or the Spot has like the follow me it's automated versus autonomous in that sense. It's you define the thing and it will operate that same loop until something gets in the way, then it stops and calls the operator, right? And so in that context, it's a great scenario for someone like Exyn, because we can add to that capability with both enhanced scanning, but also the autonomous navigation that gives them the flexibility of, okay, go just figure out what's in here, find the way in which we can get the best data along the way.
I wanted to play the video with the Spot. So what's happening here in this video?
Yep. So as before, you can see the unexplored voxels here, the white cubes. These are the areas where it's trying to explore. So in this case, you can actually see how the robot is thinking here when it puts this sort of green dot out in front of it, and then the trajectory path for how it navigates to try and minimize the unexplored frontier. So you can see it pushing forward here. We put some specific obstacles there to give it something to explore behind. So you can see it going around behind it, and how it is pushing that frontier. The real-time scan obviously is being created with the point cloud. But this is just an example of how a ground system would work versus an aerial system, because it's different constraints, right? You have a lot more flexibility in terms of duration, because the battery lasts longer for a ground system. But you can't go up and down in the z-axis, right? You can't fly over things. You always have to navigate around, or you have to find a path that has like stairs or a ramp or something like that you can transit up in that context as well. And so it's the same core autonomy, different vehicle model, and some different constraints on how you navigate, but same general sort of use case in a sense.
Mm-hmm. What are your typical use cases for your solution?
Mm-hmm. I would say the two most common are either exploration data collection or inspection. And so in these cases, the exploration could be the full exploration model, which is just you draw a volume around something and say explore whatever you can, come back with your 3D model, or it could be, I know generally what the layout is and I want to just transit. So you might throw a few waypoints and the system will scan all along the way and it'll transit back. The inspection use case is a little bit different. The focus there is you define sort of an inspection plane in whatever shape that is. But the idea is that you want to get fairly close and you want to define the orientation, because you're probably capturing visual and maybe other sensors as well as the LiDAR. And so you're creating like a rich data model that probably includes high-res photography, the LiDAR, also things like radiation or temperature or something like that. And so in that context, you have a much richer data model, but it's a different mechanism of using the autonomous system to define coverage map and how you capture the data.
Mm-hmm. You mentioned before the SDK support and partnerships. Can you just give me like more information? Because if I understand right, it's not only about like we sell this solution and you can buy it. It's actually about the collaboration with different companies and different solution developers and creators. So can you just
Absolutely.
explore this more?
Yeah, 100%. So we have a whole category where we work with OEMs, and in our parlance, an OEM is both a original equipment manufacturer of drones or robots, but also people who build product on top of our core capabilities. So we have some folks that build software that sits on top of ExynAI, which is our software suite, and some folks that are integrating our autonomy or SLAM or both. Our mapping tools into their physical systems, drones or ground robots. And in those cases, we provide the SDK, which is a software development kit, allowing them to do the integration themselves. We obviously provide support for that stuff as well. And then we have these tool sets to allow for real-time access to the Nexys as well, through an API structure where if folks want to integrate the Nexus and access the data in real time and build product on top of that, either real time analytics or post processing tools, whatever they want to do. That's also an option to work with partners. So we do that in a whole bunch of different scenarios. We've got some really great partners out there putting product in the real world.
When you say ExynAI, which
Mhm.
part of the overall solution
Yeah,
this is?
ExynAI is just how we refer to the entire software suite, including
Okay.
mapping, autonomy, and post processing.
Okay,
Mhm.
fine. I could see that you have a whole distribution channel of
Mhm.
partners all over the world. What is your current stage? Like, are you already filled with the partners, or is there a possibility
Mm.
for new partners to come into
We
this
are
game?
we are always looking for good partners. We have coverage in a bunch of regions, but not all. We're especially looking for partners across Europe and Asia. Um, we have a lot of growth in our geospatial business, especially OEM as well. And we're looking for partners all over the place to help us sell, help us service. We're also looking for folks that are exploring new use cases and want to think about how we can help there.
From what we have discussed so far, it's clear that you are not just another slime company. So, could you just give me like brief idea about how do you divide the hardware and software part,
Mhm.
and in terms of money, like where do you sit? Like, we don't have to be very specific, like, but
Mhm.
just give me at least the range, and to our audience,
Yeah,
like what we are speaking about.
yeah. I mean, I would say our software and our hardware teams collaborate daily. They're co-located. We don't view the software as being divorced from the hardware in the sense that it needs to work tightly with it, but it also needs to be packaged enough so that it can be utilized by third parties using different hardware, and it has to operate on its own also. So we think about it a lot as really interface engineering in a lot of senses. It's the core modules all need to work really well, but they need to work well together and in a clearly defined way so that it is a scalable tool set. And this approach, I think, has given us modularity and flexibility in how we deploy the tools. It also means that we have to maintain a rigor internally to maintain the clarity of those interfaces, the documentation, all that stuff. It's often the little stuff that falls by the wayside that ends up making problems. So we got to keep on top of it, and that's a big piece of how we've driven the engineering culture.
Okay, I will not leave you because I haven't heard the number, or at
Oh
least the
yeah,
range. So,
yeah.
can we go
Yeah,
back?
I mean, I would say our typical sale is somewhere between like 75K and 140K, depending on what all people are purchasing. Sometimes it includes a drone, sometimes not. Sometimes it's the scanner itself. Sometimes it includes the autonomy license. There's a whole bunch of different ways in which you can pull it together.
Does
But
uh, you mentioned before that it's very connected, very closely connected, the
mhm.
software and hardware part.
Yep.
Like, what is the reason for not buying the hardware from you and just the software
Mm.
part?
The end user would either buy the hardware from us or from a third party. An OEM would buy the software, the SDK specifically, if they were trying to build like a really integrated system.
Mhm.
Um, and then a lot of times it's not one or the other. It may start with one and move to the other. The easier integration, the faster integration is probably with a Nexus, accessing it through an API, using that to integrate with their existing hardware, and then that informs them enough for what the next version of their physical platform might be. And so they go, we learned enough from this. The next time we're just going to use the SDK. We'll buy all the physical components and integrate them ourselves, which is also fine. Either of those outcomes are positive for us. Gets our technology out in the world.
Typically, every development company has some plans and some roadmap. what is on your roadmap? If you can
Yeah,
take us to your
yeah,
brainstorming sessions and
sure.
your vision for the next
Mhm.
3 to 5 years, for example, like
Yeah.
where do you see Exyn going?
Sure. Well, you mentioned previously that we're recently a public company, so I have to be a little bit careful about how specific I get. But
Okay.
I'll say more broadly, and I mentioned this at the beginning as well. Our broader vision in all of our markets is this continuous, ubiquitous digitization. So how do you have systems that are out there doing the work for you, getting information, updating your model of the physical world in whatever space that is, whether that's industrial, geospatial, maintenance, digital twin, mining, whatever. All of those benefit from an updated digital model that you can run simulations on, understand current state, run data work, all that stuff. So all of the things that we're working on go towards that end. How do you support more standalone autonomy? How do you support a broader array of physical systems that can then gather that data? So it goes from like a single drone to lots of different types of drones that can be in different use cases, different sizes, different access criteria, uh, different kinds of ground vehicles. We already support quadruped and some wheeled vehicles. We'll continue to expand that support to different types of systems. We fairly recently support maritime capture, where you're on, a small boat that is capturing data, either hydrographic or above water or both. So it's pulling all of these together and pushing that forward in a way that removes removes the direct link of one operator to one system, and instead becomes a manager of systems, a manager of data collection, basically. And so you increase your ability to and your reach to gather this data accurately, continuously.
I have a tricky question for you. Uh, Steve Jobs was always saying that you need to do software and hardware at the same time. Otherwise, you're
Mhm.
leaving money on the table and you're making it easier for the
Yeah.
competition to get you.
Mhm.
Uh, but still, from the future point of view,
Mhm.
it might be difficult to keep the same level of the development with the hardware
Mhm.
and the software part. Do you like have preference for the future?
Mhm.
Maybe you as a person, but maybe you as a company.
Yeah.
Like if you had to get rid of one of those, like which way you would go?
I don't think we have the luxury of doing that. Both are required because our systems operate in the physical world. You can't do away with hardware entirely. I think we would lose some of our relevance if we didn't have any hardware. That said, I think our maximum reach is going to be driven by a software first mentality. It just has to be developed in line with what we know the physical systems require as well. So we're not operating as an internet company because we're operating in the physical world, and so we don't have the luxury of being all digital, all software. I think it is a critical piece to sort of remember that. While at the same time, I think a lot of our growth is going to come from software oriented
But
tools,
but that
SDKs.
that is that's exactly what I'm asking
Mhm.
because it leads me to the idea of the collaboration and the
Mhm.
openness and the bridging of
Yeah.
your software with all the different slam producers and possibly other solutions for the future. So this would support the idea that like the software part is more important than the hardware.
Well, yeah, I mean, it forms the basis for our differentiation, but it is only as relevant as the physical system is able to support. And
Mm-hmm.
so, we could develop some really awesome software, but if it's then constrained because we didn't plan for how the physical system uses it, doesn't matter. And
Mm-hmm.
so, that's what I mean by we need to develop with both in hand because it's being used in the physical world.
Yeah,
And
yeah.
so I think that's the critical piece for us. I still think as it has been to date, most of our core intellectual properties in the software. It's our differentiation. It's the reason why people buy. But we have to have the hardware tools that allow people to utilize that software. And so right now, that's the Nexus. It could be other forms as well. And it often is other partners as we get it out in market with those folks. So it's a linked development cycle for us.
Is there been anything that we didn't touch and you think that is important to mention?
Yeah, I mean, look, I'll just reinforce what we did cover, which is, we are always looking for new partners, whether those are OEMs, robotics providers, drone builders, etc. We work with a bunch already. We're trying to find, the best players in every category to help them get to market faster. Similarly, we're growing our channel and distribution network. Would love to talk to folks that are in the market.
If you're interested in the collaboration and partnership with the Exyn Technologies, Ben is the right person to talk to and get in touch. You can find him on a LinkedIn. He's quite responsive. I have tried it, so so feel free to get in touch with him. Thank you so much for doing this. It was a really
My
great
pleasure.
conversation.
It was great. Thank you.